This lecture is part of an online course on multivariable calculus, and I'm gonna talk about limits and continuity. So let me start. If I want to give you a recall, I'm gonna say that in one variable calculus we wrote limit of f of x as x goes to a point x naught is equal to L if we have this situation. This x-axis, this is y-axis, and I have like just the parabola like this, y equals to x squared, and then we say that, for example, at the point 2 we wanted to find the limit. We say the limit of f of x as x goes to 2. If we go to the point 2 from the right, we just assume that we pick this point and then we go to here. We are getting closer to the point 2. We're getting this point, and then very, very close to the point 2 we get to the point 4. And if we go to the right, if we go to the point 2 from the right, or if we go to the point 2 from the left, we're gonna get this and then that. So we're gonna get closer and closer to the point 4. That's why we say that the limit of f of x as x goes to 2 is equal to 4. This is the similar situation when we have a function of two variables. We say, like as usual, we write the limit of f of x and y as x and y, or variables, go to the point x naught, y naught, and we say that the limit is L if we have this. We say that f of x and y become closer, arbitrary closer to L when x and y is sufficiently close to x naught and y naught. Okay, so in 3D we have a shape like this: x-axis, then we have y-axis, and we have z-axis. And just assume that we have a parabola, actually paraboloid like this, and just picking just one point in here, for example the point 1 and 2, then we say that this parabola f of x and y, which has the shape the x squared plus y squared formula, we're getting closer and closer to the point 1 and 2, and then we're gonna find the values of each one of the points that we pick to become closer to 1 and 2, and then we find the limit. Okay, let me show it to you in the graph of the paraboloid. So you see, that's the graph of the paraboloid in R3. And if we pick just one point in here, for example the point 1 and 2, when we take the values of any point that is closer to that, we see that the limit is like this. Like this. We say that the limit of x squared plus y squared as x and y goes to the point 1 and 2. You can just pick any points close to 1 and 2, and then you see that we're gonna get 1 squared plus 2 squared, which is 5. So the limit would be 5. But it's really important that in one variable calculus, when we go to the point 2, we just move on the x-axis, but here in R3 we can getting closer to the point 1 and 2 in various ways, along this, along that line, along this curve, along that curve. So there are tons of ways to getting closer to the point 1 and 2. That's why we write this. So as a note, x and y can approach to x naught and y naught, and basically x is getting closer to x naught and y is getting closer to y naught in various ways. Basically infinite number of ways, infinite number of paths you can choose. Like we can approach the point on the lines or curves or different curves. So lines and curves. Okay, now, so that was kind of like introduction for the limit. Let's go to continuity. And for continuity, I'm going to give you the recall of a continuous function in one variable calculus, when we say that when x is getting closer to x naught, if we get f of x naught, then we say that the function is continuous. Okay, for example, in the case of the parabola, if you have the parabola like this, y equals to x squared, as x is getting closer to 2, since the limit of x squared as x approaches to 2 is equal to 4, this is the value of the function at the point 2, the value of this function at the point 2. That's why we say that this is continuous. This is the same case for defining continuity in the function of two variables. So continuity, we say that the limit of f of x and y as x and y goes to x naught and y naught, it's equal to f of x naught and y naught. Okay, so we should check that the limit exists and equals to the value of the function at the point. It's important. Okay, so we use continuity. Let me give you a note. In two variable a function of two variables, we use continuity to show that the limit exists. Continuity to show that the limit exists. So how? We're going to say that if the function f is continuous at a point x naught and y naught, to take the limit, just plug x naught and y naught into the function f. Okay, so what are the functions that are continuous, so that I use their continuity to find the limit, the same standard continuous function in one variable calculus? We're going to say that standard one variable continuous function are continuous in two or more variables. In two or more variables. Like what? Like, for example, constant functions. Constants. Like polynomials. So constant functions like this. For example, f of xy equals to some number. Like polynomials. Polynomials, the function could be like this. Let me write this. F of x and y equals to, for example, x squared minus 1/2 xy. Something like that. No square root and no fraction. No trig function in it. Actually, trig function are also continuous. So, for example, f of x and y equals to sine of x or y. Okay? Or cosine. Then we have the sum, product, quotient, of continuous function or continuous, and also compositions of continuous functions. Composition with continuous function. So as you see, basically everything that was continuous in one variable calculus, we can kind of generalize it for two variable calculus as well. And all you need to do is to watch out for division by zero. So watch out for division by zero. Watch out for square roots of negatives. Watch out for a log function, log of 0 or negative, anything like that. Let me give you just one or basically two quick example in this video. So example 1. What is the limit of 5x squared z plus zy cosine of pi x minus pi z as x and y and z goes to 2, 1, and then -1? So you see, what do I have in here? I have a polynomial in here. I have a polynomial and a trig function. Both of them are continuous. That's why their product is continuous. Now I'm going to plug in the points into here. And since everything is continuous, the limit would be the value of the function at the point. So I'm going to have 5, 2 squared times -1 plus 1 times -1 cosine of pi times 2 minus pi at -1. So this one would be -20. This is negative. How about in here? I have 3 pi. Cosine of 3 pi would be -1. Negative would be positive. So I get -19. Okay. And example 2 would be the limit of xy over x squared plus y squared as x and y goes to the point 3 and -1. And in here I have a continuous function on top, a continuous function on the bottom, and the denominator is not 0. So I get 3 times -1 over 3 squared plus -1 squared. So this is -3 over 10. Okay, so as you see, we use continuity to show that the limit exists. In the next video, we're gonna solve more examples on that.